So, good afternoon, everyone. We will just be waiting about a minute for the other attendees to join in. Just give them 1 minute to all join. Wait another 30 seconds. Ten seconds. Okay, so good afternoon, everyone, and welcome to this COP28 Virtual Ocean Pavilion. This panel is hosted by the World Maritime University in Malmö, Sweden, and the Ocean ICU Horizon Europe project. Today, our panel will address the important challenges and opportunities for managing and protecting ocean spaces by 2030. Next slide, please. So my name is Mary Wise, and I am the Professor of Marine Science at the World Maritime University. I'll be kicking off this panel where we will have 6 speakers interspersed with panel discussions. We invite you to share comments and questions in the Q&A part of this Zoom meeting, and we will share these with the panelists along the way and our moderator. Next slide, please. So as we know, humanity and our planet face 3 interconnected Anthropocene crises. So the climate crisis, the biodiversity crisis, and the food crisis. The ocean is our greatest ally in addressing these crises. The ocean cycles and stores carbon and regulates our climate and offers coastal protection. It is rich in biodiversity, most of which is undescribed. And it also provides, it is also a source for fisheries and aquaculture, which is important for food security throughout the world. Next slide, please. Okay. But unfortunately, the oceans, our greatest ally, and the benefits that it provides to the global commons is under threat from a cocktail of human activities. These human activities exacerbate the impacts of climate change, biodiversity loss, overharvest, and destructive harvest. This Anthropocene cocktail weakens the ocean's capacity to buffer the effects of climate change, biodiversity loss, and to support food security for a growing population. Next slide, please. So globally, we have witnessed an explosion of human activities in the sea as industries move into coastal waters and offshore. This explosion has intensified and diversified in recent decades and has been dubbed the blue acceleration. Many countries have adopted a blue economy agenda to expand industrial activities into the sea. So, for example, the expansion of the shipping sector, the expansion of offshore energy resources, the expansion of tourism and marine aquaculture. So many of these countries that have expanded into the seas in this way are, of course, they're in pursuit of some societal benefits, but these societal benefits that may be important for some dimensions of sustainability must not weaken our life support system. The integrity of our ocean and climate, often depicted and discussed in SDG 13 and SDG 14, respectively, are non-negotiable. These relate to our climate and our oceans and must underpin decisions concerning the expansion of human activities into the oceans and the coasts. Next slide, please. So the ocean needs protection, and substantial and effective ocean protection can yield climate, biodiversity, and food security benefits. Sala et al. In this article showed that most coastal nations contain priority areas that can contribute substantially to achieving these 3 objectives of biodiversity protection, food security or food provision, and carbon storage. Moreover, they also showed that a global coordinated effort could be nearly twice as efficient as an uncoordinated national level conservation planning approach. But what are the most important areas to protect? And how do climate and biodiversity and seafood biomass areas overlap in space and time? Next slide, please. We have a number of management tools that are rooted in area-based management that can help us to achieve these goals. Area-based management is the regulation of human activities in a specified area to achieve conservation or sustainable resource management objectives. Examples of these are marine protected areas, which are areas that are set aside for conservation with restricted human use. There's marine spatial planning, which is a potentially complex zoning practice where certain human activities are allowed in some places, but not in others. And then there's also environmental impact assessment. This is a process to estimate and predict the potential impacts of a proposed project on the environment prior to the decision to move forward on a particular project. Next slide, please. There are also a number of policies to support area-based management. And area-based management plays a central role in delivering the new Kunming-Montreal Global Biodiversity Framework. I'll explain a little more in my next slide. So the Kunming-Montreal Biodiversity Framework includes several ecosystem-based targets to support area-based management that if effectively delivered, can potentially support the protection of biodiversity, climate, and food security. In particular, Target 1, all areas, that is the entire territory of each country, are to be under effective spatial planning to bring the loss of areas of high biodiversity importance close to zero by 2030. By 2030, at least 30% of degraded areas, so land, inland waters, and sea, should be under effective restoration. Target 3, 30% of the world's oceans and coasts should be in protected areas, marine protected areas, and this is by 2030. Also, Target 7 aims to reduce pollution risks, and Target 8 minimizes climate change and ocean acidification impact and bolsters nature-based solutions and ecosystem-based approaches. All of these together, if effectively implemented, could bolster not only just biodiversity, climate benefits, and also benefits for food security and other ecosystem services that are provided by the ocean. Next slide, please. So a marine protected area, and if I can just go a little bit more deeply into marine protected areas, there are many different definitions for these, but I'll go with the IUCN definition for today, and this will suffice for our purposes of our panel. This is any area of the intertidal or subtidal terrain, together with its overlying water and associated flora, fauna, historical and cultural features, which has been reserved by law or other effective means to protect part or all of the enclosed environment. Marine protected areas can benefit nature and people, and the rationale behind marine protected areas is that removal of sources of impact leads to an improvement of the system over time, unless the damage has been irreversible already. Next slide, please. So how much biodiversity, or how much of the world's oceans and coasts is currently under protection? Currently, about 8.1% of the world's oceans and coasts are under some form of designated protection. But there's also been a rapid growth in recent years due to the creation of very large marine protected areas, for example, those in the Pacific or off the Antarctic ice shelf. Next slide, please. The objectives are essential in designating marine protected areas and also in area-based management in general. We cannot manage what we cannot measure. And so from the outset, we need to be very clear about what we're protecting. What are we protecting it from? Who is protecting it? How will it be done? And who and how will this be decided? The Convention on Biological Diversity offers some considerations for marine protected area success. And these considerations offer challenges for science, management, and also for governance. The previous slide, thank you. So some of these challenges that, some of these considerations that the Convention on Biological Diversity recommends are that we ensure that the areas that we put aside for protection are adequate, meaning that they're big enough and that they're numerous enough, that they're representative, that the features that we actually want to protect are actually there and represented within the areas we're trying to protect, that these areas are well connected in order to help maintain the life cycle of the parts of the ecosystem we're trying to protect, and that also we don't put all of our eggs into one basket, and that we have some degree of replication or duplication in the marine protected area network in order to help promote and build resilience. Tying all these things together is management. And studies have shown that effective management is essential for MPA success. Things like staff, monitoring, resources, and enforcement are essential to achieve protection objectives. Next slide, please. So this is actually a paper that was published by Gill et al. In 2017. And a number of papers have emerged to examine this phenomenon even more deeply. So this article evaluated the effectiveness of management in marine protected areas globally. And the conclusion of this paper is that paper parks, they really don't help, and effective management is essential in the forms of staff, monitoring, resources, and enforcement. Next slide. So the biggest, so there are a number of policies to support area-based management, and they depend on where we are in the world. Different policies will apply to different parts of the seabed or the surface, in the coastal areas within a country's EEZ, in the continental shelf, or in this case beyond. And one of the biggest opportunities for protecting the ocean for biodiversity, climate, and also for food security is the Biodiversity Beyond National Jurisdiction Agreement. And this agreement is actually the subject of the next panel that we're going to hear from today. The High Seas Treaty, as it's also called, highlights in its principles the importance of an ecosystem-based approach and also integrated approaches. It also highlights the importance of carbon cycling services that underpin the role of oceans and climate. This is an important opportunity to protect the ocean for biodiversity and climate goals with food security benefits. And we'll be talking about some of these opportunities in today's panel as well. Next slide, please. So here we're looking at our global ocean, and this is a map that we're going to see later in one of our other panel presentations by Dr. Fabio Berzaghi. This map is showing carbon that is stored for at least 50 years, along with the EEZ boundaries of the different countries throughout the world. And looking at our global ocean, we can see tremendous opportunities through the BBNJ agreement, or the High Seas Treaty, and the Kunming-Montreal Agreement to protect 30% of the world's oceans and coasts for their carbon services through the biological carbon pump, biodiversity, and fisheries. The question is, how do we balance the protection of the biological carbon pump, biodiversity, and fisheries when the most important places may not necessarily overlap in space and time? So in our panel discussions, we'll address this question. And we'll also address questions of how do we address multiple objectives to manage ocean spaces for biodiversity, climate, and people. And then we're also going to address other questions that are essential for trying to make progress on these objectives by 2030. Next slide, please. So today we are going to hear from a number of speakers. The discussion is going to be moderated by Dr. Pernilla Schnoor, and we're going to unpack some of the following questions. We're going to look at the science that we need to support decisions about how to manage ocean spaces for biodiversity, climate, and people. We're going to look at the dynamics of our ecosystems in space and time, but also the dynamics of human activities and also the decisions that are being made by policies and also regulations throughout the world. We're going to discuss management. We're going to discuss how to co-locate our biodiversity, climate, and food security benefits and to protect these. We'll talk about capacity sharing and building and how to meet this ambitious objective to protect so much of the ocean by 2030. We're going to talk about governance, policies, regulatory and non-regulatory options, and then we're also going to talk about conservation finance. The discussion will be moderated by Dr. Pernille Schnoor, who is a senior researcher at the World Maritime University and a former member of the Danish Parliament. We're also going to hear from Dr. Richard Sanders, who is the OTC director at NORSE in Norway and also the coordinator of the Ocean ICU European project. We're going to hear from Dr. Patrick Lehodet, who is a senior climate fisheries scientist at the Mercator Ocean International Institute in France. We'll hear from Dr. Marinês Scherer, who is the general coordinator at the Ministry of the Environment and Climate Change in Brazil. We'll hear from Dr. Natalia Gallo from the Department of Biological Sciences at the University of Bergen in Norway, and then also Dr. Fabio Berzaghi, who is a senior researcher at the World Maritime University in Sweden. So next slide, please. So without any further ado, it's a great honor to introduce Dr. Richard Sanders from NORSE in Norway, who will talk to us about the science we need to evaluate the roles of MPAs in the ocean carbon cycle. Over to you, Richard.
Thanks very much, Mary, and thanks very much for your fantastic overview of some of the key issues that we're going to deal with in this panel and some of the key issues that ocean science faces in regard to the ocean biodiversity climate crisis nexus. Could I have the next slide, please, Peter? So Mary asked me to say a few words about the science that we need to try and understand how this tool of the marine protected area can affect ocean carbon cycling. And I thought I'd start by just showing these two pictures. One is from the IOCR, so that's the Integrated Ocean Carbon Research document that was published in 2002, and the other is an earlier version or a sub-part of the one of the diagrams illustrating the global carbon cycle published by the IPCC a few years ago now. And the headline message that I wanted to give is that the current perspective is that the biological and coastal carbon cycles are unaffected by human activity. Now, I personally find that quite difficult to understand and believe, but nevertheless, that's what our current perspective is. And I think that's illustrative of the amount of work that we need to do to kind of understand this. But just drilling a little bit deeper into these diagrams, what's quite noticeable is that the red numbers, which are those that have been perturbed by human activity, are really dealing with the communication with the atmosphere, whereas the black numbers are very substantially associated with the intra-ocean redistribution of carbon. Now, much of that, indeed most of it, is actually a physical process. So the oceans take up and store and release a lot of carbon physically, and that storage is very important because it keeps carbon in the ocean rather than the atmosphere. But in addition to that physical storage, there's also this biological term that we term the biological carbon pump. On the left-hand image, you can see that in the black arrow that's links surface biota to the interior. That's from a whole variety of processes that I'll speak about in a minute. And on the right-hand side, you can see some of these black processes are burial in the coastal zone, rivers. So these are processes that are taking place that we feel much more research is warranted into. But dealing specifically with marine protected areas, I want to say a little bit about how marine protected areas and ocean carbon cycle science intersect. And in order to do that, I'm going to describe a little bit about what that black arrow is, the 11 gigatons of carbon that's transferred from the surface to the interior annually. So next slide, please. So this is a schematic that we've drawn up within a large EU project that we're involved with. And what it shows the series of processes that are responsible for transferring biological carbon or carbon biologically to the interior. And the chief message from this is that it's incredibly complicated. Ocean ecosystems are beautiful, they're exciting to look at and interesting to study, but they also store a great deal of carbon in the interior. There's a range of processes that do that. They all begin with the growth of phytoplankton in the sunlit upper ocean, utilizing energy from the sun, and then that carbon is transferred into the interior via a whole range of processes, including gravitational sinking, which is a significant but isn't the full story. The complexity of the marine food web means there's a whole range of organisms involved in this. So you consume that phytoplankton that produce fecal material which sinks, that swim up and down in the water column, excreting material at the bottom that die and are sink to the bottom. So these are the sets of processes that are shown on the left-hand side. And on the right-hand side is the sort of human intervention in this that takes place now. So we extract protein from the ocean, we dredge the ocean, we drill the ocean, we potentially may mine the ocean in future. And this set of activities has the potential to intersect with this complex food web that's itself storing carbon in the interior. So given the way that MPAs operate and the sort of activities that they're stopping, this is the context to think about this problem. Next slide, please. So this brings me on to what is a marine protected area, and I don't have to labour this point because Mary's given such a nice introduction. But the crucial thing is that there's a control over human activities. So some of the activities that I spoke about, in the previous slide, fishing and aquaculture and mining and so forth, are reduced in intensity or absent from marine protected areas. And on the right-hand side, you can see one realisation of where marine protected areas are from the Britannica and Scientific. Next slide, please. So to my mind, the question becomes, what effects do the key processes that MPAs regulate have on the ocean carbon cycle? So if we think about it, fishing, which is a major thing that humans do to the ocean, if we ban it or reduce its intensity in an MPA, what we're effectively doing is we're stopping that biomass extraction, we're reducing deadfalls or bycatch, and we're potentially restructuring the ecosystem quite significantly by removing different trophic levels. And then that set of activities that are intervening in the ocean, mining, trawling, dredging and drilling, one common feature that they all have is they all generate a lot of sediment. And that sediment has the potential to interfere with some of that biological carbon sequestration. So these are two suggestions for areas that we might want to think about understanding more to evaluate how marine protected areas control the ocean carbon cycle. Next slide, please. So I've just got a couple of examples here. This is a simple schematic we put together that talks about what we term a trophic cascade. So the idea is that a food web consists of multiple levels of organisms, starting with small organisms that graze on phytoplankton that are consumed by larger fish and then eventually consumed by higher target or higher trophic level target species. And what fishing does is it extracts those target species, and that has a propagating effect down the food chain. So on the left-hand side, you can see a relatively unperturbed system, high levels of biomass at the top of the pyramid, smaller levels in the interior, and then higher levels at the bottom. And then in contrast, on the right-hand side, where we extract food, we see a reversal of the pattern, and the consequence is potentially that there's a reduced level of carbon flux driven by those zooplankton sitting on the bottom of the food chain. Now that's a sort of a theoretical paradigm or a theoretical model. The extent to which it actually is delivered in reality is something that I believe is a frontier question. Next slide, please. But people are beginning to address this. This is a very famous paper now that suggests that the historical fishing has reduced by about 50% the intensity of fisheries and the intensity of organic carbon produced by them. And so that's suggesting that this could be a really quite significant feature in ocean carbon cycle. Next slide, please. So if we think about sediments, these are again important questions to think about in the context of industrial exploitation. Sediments add density to sinking material, they adjust light fields, there can be remobilization of existing carbon stocks in the interior, and they can disrupt the feeding behavior of some key organisms. So all of these are areas where, if we want to understand the effect of human exploitation of the ocean, and by extension, what happens when we restrict that in a marine protected area, these are frontier areas we need to be thinking about. So I've got one more slide, please. This is just making the point very visually that that some of these midwater ecosystem some of these mining activities really have the potential of generating plumes both at depth and in midwaters that can interfere with some of these key processes in the ocean carbon cycle. And I'll stop there and hand over to the next speaker. Thank you.
Thank you very much, Richard. So that was excellent. And yes, I look forward to discussing the mesopelagic and impacts on the biological carbon pump from human activities in our discussions. So at this point, it's a great pleasure to introduce Dr. Marina Scherer from the Ministry of the Environment and Climate Change at Brazil, and she is an expert on marine spatial planning and is coordinating many of the scientific activities in connection with that in Brazil. So over to you, Marinez, and thank you very much for joining us.
Thank you, Mary. Thank you very much for inviting me for this great session. So I will be talking about ecosystem-based approach for marine spatial planning, why it is important. So next slide, please. So as we just heard now, the ocean coastal zones support life and provide the necessary ecosystem service. Next. So, and what are ecosystem services? So ecosystem services are the benefits that people obtain from ecosystems. So everything that benefits us from the nature, from the ecosystems, we consider that ecosystem service, and it depends on the health of the ecosystems, and the case in the health of the oceans. Next, please. So we have different kinds of ecosystem service that I say that we put that in little box because we have to understand it, but actually they interact and they are together in the same ecosystem and habitats. But if you can talk about types of ecosystem service, you can talk about the provisioning service, that the ones that we can understand that it quite easily, because the ones that you get straight from nature, like food or biomass of fish, for instance, water, different minerals, we can put that oil and gas as well. We have the regulating service, the one that help us to regulate climate, for instance, that we are just listening to in the previous talk, or for instance, the ecosystems that control erosion and protect our coasts, like mangroves or coral reefs. The marine supporting service, they are considered service, but they are also considered the functions of the ecosystems, like nutrient cycling, the carbon cycling, primary production, or the area that we use that supports our activities. And the last but not the least, the marine cultural service that are so important for us, a landscape, recreational, spiritual, or it means the connection that we have to the ocean and coastal zones. Next, please. Here's a graphic that we can see on the left side, ecosystems or habitats, and the middle, we have the ecosystem service, and the left column, the economic sectors or economic activities. So you can see clearly that our activities, use and activities, they depend, they rely on ecosystem service, and the ecosystem service are coming from the ecosystems and the natural habitats. So we can, for instance, tourism, it will rely on the landscape, it will rely on the food that we can get from the ocean, it will rely on the coastal protection. Otherwise, we cannot have tourism or beach tourism, for instance. Next, please. So just a glimpse of the lot of activities that we have in Brazil, for instance, on the ocean and coastal areas. So that's a lot of layers put together, but you can see that there is no empty space on the ocean. So we are using it, and we have to plan and to manage our use in order to not affect the ocean ecosystems and in order to not affect the ecosystem service. Next, please. So, but our use and activities leads to a lot of different impacts, like the climate change that we are just talking, overfishing, contamination, the solid waste, especially plastics in our ocean that are high problem, habitat suppression, degradation, the tourism that are not planned, or any other activity that is not planned, like oil and gas extraction, or wind power generation, or emissions from our maritime transport. So any activity that's not planned will cause an effect in our ocean. Next, please. And you can ask, okay, I know, but what's the problem? So the previous place, so yes. Well, the problem is to lose the ecosystem service that will lead to lose the ecosystem health and social well-being. Next, please. Because, as I was saying before, it's a cascade, it's a flow. If you have the ecosystems, biodiversity, structure, and function, you have the service, and the service leads to benefits and ultimately to value, cultural, social, and economic values. Next, please. So what happens when one of the links is broken? If you don't have more the ecosystems, structure and function, you don't have more the service, we don't have more the benefits. It's that simple. Next, please. So we do need to have an MSP or marine spatial planning or any kind of plan and management in the ocean. It has to be ecosystem based. Next, please. One of the main principles, or the first principle on marine spatial planning, is that it has to be based on ecosystems, because it balances ecological, economic, and social goals and objectives towards a sustainable development. We have other principles, but that's one of the baseline for marine spatial planning. Next, please. So this information, which kind of ecosystem, which kind of ecosystem service we have, which benefits, and who is the beneficiary, or it means who is benefiting from this ecosystem service, must be incorporated into MSP. Next, please. And different countries, regions, and cultures, you use that in a different way. You can use that as a very effective tool to increase public recognition on the value of ocean and coasts. People will understand that they lose benefits if you have impacts in our ocean. We can identify key areas needing protection, the areas that deliver the most important ecosystem service, or the areas that we have to protect to maintain the ecosystem health, the ocean health, in order to deliver the ecosystem service, in order to help the ocean to help us. It helps guide development sustainable ocean economy when we understand that our economic activities rely on ecosystem service and rely on the ocean health. We start to understand that's so important, the conservation of the ocean. Understanding that allow us, the decision makers, to understand trade-offs. It means where can I develop an activity? Where is the less harmful area or the less harmful activity? And how can I protect the ocean health? And at the end of the day, we just monitor the health of the environment and ultimately our own well-being. Next. That's it. Thank you for that. That's all for me.
Thank you, Marinus. That was excellent. That was excellent and very inspiring. So now it is a great honor to introduce and hand over the floor to Dr. Pernille Snoer, who's a senior researcher at the World Maritime University and a former member of the Danish Parliament. And she is going to lead a brief discussion with our panelists who've spoken so far and the other panelists as well who may want to contribute for the next 10 minutes or so. Now over to you, Pernille.
Thank you so much, Mary. And thank you for your great presentations. And now we've heard some interesting presentations about your research. And I would like to focus also, because this is part of COP28, also on the roadmap to political impact and action as well. I think I'd like to ask a question at first to you, Marinus. We heard in your presentation that you talked about no empty space on the ocean. You also said that we lose social well-being. And you also mentioned that we need to help the ocean to help us. If you would suggest something to political decision makers, what would you suggest? Could you briefly say something about that?
What I would suggest to myself, I would say now. Yeah, well, I think marine spatial planning, it's a great tool to try to organize all these use and activities in the ocean in order to protect it. The key areas that needs protection, I mean, the whole ocean needs protection, but we do need, we have these activities, and these activities are important for our society as well. So we need to balance it, and putting everybody in the same table and discussing, having this ecosystem-based approach. It means the main goal is to protect the key areas, to protect ecosystem service, and then organize the activities around this idea. So marine spatial planning is very important for that, and marine spatial planning leads to marine protected areas as well. When we recognize the areas that need, the key areas that need protection, and that they will be important not just now, but in the future, if you take the climate change scenario, so we can design better protected areas. So putting everybody together, including the conservation idea of protecting areas in the same table, I think is the only way to get a good and healthy environment for our ocean and for ourselves.
Thank you so much. I will ask you, Mary, because we have a question in the Q&A as well, yes. From Sahan. And you are asked, what type of mechanism is required for management of MPAs in APNJ, as there are no effective jurisdiction? That's the question for you.
Yeah, that's a very, very good question. And so right now, the most important thing about the BBNJ treaty and BBNJ agreement is that it be ratified by all countries, so that these, these practical things, such as setting up our marine protected areas in the high seas, can start to happen. But this is also something that is going to take some time. And so after the treaty is ratified, then it will enter into force. There will have to be a COP. There will be a conference of the parties for the BBNJ. Those countries that are interested in seeing the establishment of a marine protected area in a particular place will then get together, and they will then apply to the COP for the creation of the marine protected area. And then at the same time, they must also propose a mechanism for monitoring and managing this marine protected area as well. This is going to require a tremendous amount of effort from science, from technology, science to decide where the marine protected areas should go. A policy as well to get these countries to support the marine protected areas in these in the high seas. It's also going to require a lot of diplomacy as well, scientific diplomacy. The different countries need to collaborate in order to help make these decisions. And also it's going to have to require a lot of negotiation because there are so many sectors that are interested in activities in the high seas. So we heard from Richard earlier about the threats from deep sea mining, from fishing, and so on, and also from international shipping. So how can we? So these things will need to be considered. And also, I want to point out too is that because this is an area that is going to receive a detailed discussion in the next panel that's going to happen after this, because that's focusing on the legal dimensions of the biodiversity beyond national jurisdiction treaty, and then also its implementation and how marine protected areas will be created. So there you'll be able to hear a whole hour and a half specifically on that topic.
Thank you, Mary. And you talked about diplomacy, and I would like to ask you, Richard, thank you for your very interesting presentation. This is the last day of the COP28, and I think we need to somehow also address the elephant in the room that has been fossil fuels, and whether to phase out or phase down fossil fuels. The president of the COP has recently, last week, according to The Guardian, claimed that there's no science indicating that a phase out of fossil fuels is needed. In your presentation, Richard, we have heard of the ocean carbon cycle. We have heard of the ocean carbon sink and carbon storage, which is obviously very, very important. But I would like to ask you, is there a risk that focusing on management of human activities that affect blue carbon and ocean carbon can be a distraction from the most important issues, for instance, stopping CO2 pollution from burning fossil fuels?
So that's a really interesting question. I guess my perspective on this is that we are not going to solve the climate crisis unless we make deep, rapid and sustained cuts in our emissions of fossil fuels. I think we all know that, and we all agree that. Having said that, the ocean and the land biosphere are very important sinks for carbon dioxide. About 1/2 of the carbon that we emit to the atmosphere goes into those two sinks. I don't think there's any credible evidence that we can enhance them to the point where they take up substantially more than that, although there are many, many attempts being made to deliver that outcome. There is the possibility, however, that the effectiveness of those sinks might decline, reduce in intensity, and then we would end up with a worse position than we are in now. So I guess my perspective on this is that we can't afford not to look at these natural sinks. They're so big, and the cycling of carbon through the biosphere and the ocean is so large that even very small perturbations of that could be very important. So to summarize, I guess what I think is that our primary focus is now, has been, and must be into the future in reducing emissions and developing a way to adjust our pattern of life and society to that end. But we shouldn't take our eye off the natural sinks, Paul, because those terms are large in the global carbon cycle.
Thank you so much, and I will return later with some more questions. Thank you.
Fantastic. So, well, thank you very much. That was thank you for those excellent questions, Pernille, to the panel. And now I'd like to kick off the second chapter of our presentations for today's for today's virtual ocean panel. And I'll start off with Dr. Patrick Lehaudet, who is a senior climate fishery scientist at the Mercator Ocean International Institute in France. And so Patrick, it's an honor to introduce you, and I look forward to your presentation.
Thank you very much, Mary. Thank you for the invitation. So I'm going to take the coming few minutes to give a very brief overview of what could be the interest or not of implementing international marine protected areas in the high seas. And I will use the case of high seas fisheries to illustrate this. Next, please. So just to introduce the context, so we have seen already that the human activity has a strong impact on the ocean due to different sources of pollution, habitat degradation, and also most often we associate the conservation of the high seas with the fisheries, the exploitation of the high sea species, and particularly tunas. So can high seas MPAs help to reduce this impact on the ocean and the exploitation of oceanic species? So next, please. To illustrate that, I will give a very quick panorama of high seas tuna fisheries. So it's clearly a global industry covering all the oceans from 50 north to 50 south. There are mainly two major fishing gears. One to catch a surface school of tuna, so the percent fishery, so the map on the left, top left, which concentrate in the tropical area, and you can see especially in the Pacific Western area, and the longline fishery that target larger individuals for the sashimi market particularly, while the percent fishing is providing the catch for the canoes. And more than half of the world tuna catch is coming from the Pacific area. So the blue and red colors on the right plot. And a large part of that catch come from the Western Central Pacific Ocean, which is highlighted in the map in light blue, and which is managed by International Tuna Commission, the Western Central Pacific Fisheries Commission, while the Eastern Pacific Ocean is managed by another tuna commission, the Inter-American Tropical Tuna Commission. And to finish this complex overview, we see that there are a lot of small Pacific islands, especially in the Western Central Pacific area, with large exclusive economical zones. And many of these countries, developing small countries, have their tuna resource, and they sell the right to exploit this tuna resource to international fishing fleets, and that's correspond to a very large economical revenue for these small developing countries. For some of them, it's more than 30 or even 50% of the total economical revenue of the country. So it's really important for these small countries. And to finish, one species, particularly the skipjack, is providing a large part of the catch and is targeted by the person fisheries. So that's for the panorama. So next, please. Now we can move to the interest of using spatial planning and marine protected area. So the first challenge is in MPAs, there is the A of area, and for the moment, the management of these tuna stocks, tuna population, and fisheries use standard stock assessments that have a very broad representation of the spatial domain. You see an example here with the model used by the Western Central Pacific Commission. So this model has a few large geographical boxes where data are aggregated, and using a standard equation for population dynamics, the statistical approach allows to estimate the change in the biomass of the stock, the recruitment of young fish in the population, and most of all, the impact of fishing. So by comparing the fishing impact with and without fishing. And so if we want to use this, if we want to test, we want to provide scientific advice and test the interest of marine protected areas, we need to develop some different tools that can allow to consider the spatial factor more accurately. Next, please. And this is what we do for a number of years now by developing a different model that I show here, which is called Cipodim, and that try to represent with much more detail in the spatial dynamics the dynamics of this fish species. So on these maps, you see the background color give you the density of the skipjack species that we predict with this model. Particularly during La Nina and El Nino event, and you see the impact of this environmental variability on the stocks. That's another interest of this model. It is driven by environmental variables, temperature, currents, primary production. And so we try to explain the dynamics of the species by the change in the environment and the distribution of prey, for example. And of course, the fishing has a strong impact as well. So the black dots, circles that you can see on these maps are the representation of the actual fishing effort at the same time. So you see the change during the El Nino event with the redistribution of the fish to the Central Pacific and the fisheries that follow the fish. And so with this kind of tool, we can now try to test the interest of marine protected areas. So next, please. That's what we started to do with the first example here with the what is called the Pipa or Phoenix Island protected area. So this is the yellow area on the map on the left, on the right. And this protected area has been implemented. So with it was a fishing closure for the commercial fisheries, so for the tuna fisheries. And this closure was effective at the beginning of 2015. So we did two different simulations to test the effect of this MPA implementation. One simulation, which is the reference simulation, where we have all the real fishing effort and fishing mortality simulated in the model, and the second simulation without any fishing effort to have what could be the population without exploitation. And so we can see by difference, we can see the impact of the exploitation and the impact of the closure in the Pipa area. And indeed, the closure, so we see, by the way, on the bottom left plot, the time series showing the impact of El Nino in the Pipa zone. So because of the movement of fish to the central area, so there is a peak in the area at the time of the El Nino event. But what we obtain in terms of impact of closure, it's finally no big change, because indeed the fishing effort has been displaced from this area to outside of the area. and the biomass in the pipa area for this species is completely driven by what is occurring outside of the area, because it's a highly migratory and widely distributed species. And of course, this can change this kind of, so we have the tool to test many different scenarios, and especially next, please, we can be interested to see what could be the impact of climate change on the tuna stocks and distribution. So we started to use this model to explore the future change of due to the climate change and ocean warming and change in primary production and currents. And what we get for the moment is a large degree of uncertainty, especially in the second part of the century. And the next step is to introduce, next slide, please. The next step is to introduce now a tool, to develop a tool to allow exploring different fishing scenarios for the future with quite simple options, and including spatial management, of course, so the possibility to close an area in EZ or anywhere to see what could be the impact of both climate change and spatial management for this species. And next, please, in conclusion. So the benefit of ICES ICES MPA for the tuna conservation for the moment, based on this first study, is quite limited, especially in the absence of control of the fishing effort that has been displaced, and due to the highly migratory nature of the species and their wide distribution. Of course, there are some uncertainties that we need to reduce, especially we need to have a better knowledge and modeling of the factors, environmental factors that control the reproduction of the species, their spawning ground, how they change, especially with how they will change in the future with climate change. But there are also other potential benefits of this MPA, especially they can help to monitor and control the fishing effort in remote areas. It's a way to also maintain the fishing activity in the Pacific Island EEZ, because these small developing countries are heavily relying on the tuna fisheries. It's a way to limit fuel consumption, and also there are other conservation issues to reduce the impact of bycatch and to protect species and high biodiversity spots and corridors. And I will stop here. Thank you.
Thank you very much, Patrick. That was excellent. That was excellent. So now to keep us going and minding the time, I will hand over directly to Dr. Fabio Berzaghi, who is a senior researcher at the World Maritime University, who will talk to us about the biological carbon pump, its carbon sequestration services, and its implications for management and climate finance. Over to you, Fabio. It's an honor to have you here. Thank you.
Hi, Mary. Thanks a lot for the introduction. So I will, as mentioned, I will tell you a bit about the intersection between ecology, climate finance, conservation, and these global policy and fora that we have discussed in biodiversity, climate change, and that all bring together these different issues. Next, please. So Richard Sander already explained this quite well. What I just like to say is that the biological carbon pump helps sequester carbon in the ocean for long-term storage, and is made of all marine organisms from phytoplankton up to whales. And this is called the biological carbon pump, and I will tell you a bit about how this fits into these large framework of finance and ecology and conservation. Next, please. So as I mentioned, we have all these different fora in which we discuss separate things: biodiversity, climate change, and nature-based solutions, UN, ocean decade, and so on. But if we really look into how marine organisms, which are an important part of the functioning of the ocean, fit into these global fora, they are not so prevalent, and actually they are even missing in some cases. So one important thing to do is, next slide please, is the first thing we need to do to bring this into the policy stage is starting to quantify the contribution of these different marine organisms and animals in general, which goes beyond just the blue carbon, the seagrass, mangroves, forest, and so on. So what we did, the first step towards this quantification is we published this paper, next please, in which we quantify the contribution of different type of animals in the sequestering carbon in ecosystems. So in this case, we have terrestrial, we have marine, we have fish, mesopelagic fish, next please, which are quite an important contribution. So this is the first step, because, and why is this important? Next, please. This is important because, well, we need nature to reach this net zero target. On the other side, we have a global carbon offset market, which in 2022 reached almost $1 trillion. So, and we need $1 trillion each year to finance biodiversity conservation. So while the global carbon market is developing, we cannot turn the other way, and we have an incredibly important service provided by marine organisms and the biological carbon pump, which we need to protect to keep this service going. Next, please. So what I will tell you about today is our research we developed recently, and also thanks to these global models that tell us where the carbon pump is acting and how much is storing each year. So we look at the spatial distribution of this service, we value this service based on the carbon market, and then we looked at the importance of this within national and international waters in terms of in relation to climate finance. Next, please. So as I mentioned, now we have very powerful global ocean biogeochemical models that tells us where the carbon is going, where it's going in the ocean and out of the ocean. And so we can use this information to map globally the fraction of CO2 that goes into the ocean and remains there. In this case, we decided to look at the 50 years sequestration time. So, and then we can predict, we can produce maps like these. And what can we do with maps like these? Next, please. We can look at how this carbon sequestration service is distributed across different management and political boundaries. So we can look at how much of this global carbon service is in areas beyond national jurisdiction, regional fisheries management organizations, EEZ, MPAs and EBSAs, which EBSAs are areas of important ecological ecological importance determined by the Global Biodiversity Framework. So once we look at this distribution, we can start to understand who should manage which part, which is information we didn't have before. And we can go into the more details. Next slide, please. And look at single nations. So we can quantify, well, each nation has a certain amount of carbon service within their EEZ. EZ, and then how much is covered by MPA. So we know how much is protected now, and how much we need to protect in the future. Next slide. So, and then of course, we can value this carbon service, and we see that is extremely valuable because we're talking about a service that it's worth more than 380 billion per year, just in national waters, and then it's even a larger value in areas beyond national jurisdiction. So the value throughout, if we integrate this value to 2030, we reach more than $2 trillion, $2 trillion, which is significant. Doesn't mean that someone is going to pay that money, but this is the first step to understand how valuable is in this global carbon market. Next. So, and then we can look at the importance for the economies. We can look at the importance for these in national economies, and how much of this is value is a percentage of their GDP. For example, we see that this is extremely important for, next please, small island developing nations, in which the carbon service is worth many times more their GDP. And we know these nations are the first that are dealing with climate change and need financing to support climate mitigation, climate adaptation actions. Next, please. So, on the last thing I will say is that we can also use this information to highlight priority areas for conservation. For example, here we see about the 3 by 30 initiative. We want to protect 30% of the Earth by 2030. Where do we actually go about doing this? Where do we protect this 30%? Here we can see the green areas are the 30% areas that can protect up to 58% of this global carbon sequestration. Next, please. And if I use this slide, this picture that was presented by Richard earlier, we can combine these areas and see how they overlap with these carbon hotspots. Next. So with this, I am concluding, and thanks a lot for joining us and for your attention.
Thank you very much, Fabio. That was fascinating, really exciting to see. So at this time, I'm very excited to introduce Dr. Natalia Gallo, who is from the Department of Biological Sciences at the University of Bergen in Norway. Thank you very much, Natalia, for joining us, and look forward to your presentation. How can scientific research support sustainable ocean management and development?
Thank you very much, Mary, for the invitation to be here. So this is a topic near and dear to my heart, and I think the presentations that you've already seen today have given you some really great examples of how scientific research can support sustainable ocean management and development. So really here at the end, my goal is to just distill some of the essential points that I think come out from these different examples. And then also try and put it in the perspective of scientists and other ocean professionals who may be really interested in how they can develop their research agendas to actually make an impact in this ocean management and development space. Next slide, please. So I think that as scientists, we go into the ocean or into the coastal zone and we collect data. That's what we're trained to do, and that's what we're quite good at doing. However, the problem we run into sometimes is once those data are collected, it's not so clear exactly how they inform these large processes. For example, like the COP, right? It seems there's a really big disconnect between the specific data we collect and what is happening, for example, here at COP28. And so how do we bridge that giant gap? And this is a topic that gets a lot of attention now, especially under the UN Ocean Decade, where the goal of the UN Ocean Decade is really how do we produce the science that we need for the ocean that we want? Because what we've seen over and over again is just producing more science doesn't necessarily actually lead to better management or better decision making. Certainly good science is essential for that, but we could have a lot of good science and still have a poorly managed marine area. So how do we get there? And from my perspective, I think we actually have to start in reverse. Usually we start with kind of the science and the data collection. And instead, I think it's important for us as scientists to think about being part of this discussion of what the ocean we want looks like. And who's at the table in making those decisions, and how can we connect better around that discussion before we go and start doing that actual science and the data collection, because otherwise it's a little bit like trying to design a shoe without knowing what a foot looks like or what types of conditions you might need to wear those shoes in. And so I've been part of the Early Career Ocean Professionals Network under the UN Ocean Decade. And here I really think that this is a very exciting workforce for now and the future to try and make sure that we're bringing together the scientists and the other types of ocean professionals so we make these connections better. And next slide. And so just a few brief words because, right, this is a virtual part of COP28. So we're here under the UNFCCC process. And so I think it's really important that for scientists to have their science be relevant to policy and management at the end, that at the beginning we understand how our research fits into this larger landscape. And under the UNFCCC specifically, there are certain areas we can look at for guidance in that. And so here, these are just a few that I would like to point out that I think are kind of the most relevant and the most important to know about. So first of all, there's this ocean work stream, which is a part under the UNFCCC now. So oceans have gotten a lot more attention and become a more important focus under the UNFCCC over the last 10 years. And part of what we see here is that there is an active ocean work stream. So I've provided a link there for people who'd like to check that out. And that provides guidance as to how the ocean is considered under the UNFCCC process. Additionally, now there's a UNFCCC Ocean Focal Point, Jasdeep Randhawa, and that's a person that can also provide guidance on how ocean issues are being considered under the UNFCCC. Additionally, we have great opportunities to look at policy documents that parties submit under this process in order to understand their policy priorities and how our research can support and fit into those. And those specifically are the nationally determined contributions, the NDCs, as well as the national adaptation plans that countries submit. And all of these documents can be found on the UNFCCC website. Previously, myself and my colleagues, we've conducted analyses looking at how ocean issues fit into these policy documents, how they're being prioritized by different parties. But this is very insightful in allowing us as researchers to understand where there are knowledge gaps and where there's interest around the areas that we work on. Additionally, there's the Ocean and Climate Change Dialogue submissions. This is a process that usually takes place every year now. And this is a good way to see how both parties as well as non-party actors, so different stakeholder groups, different NGOs, how they're viewing ocean issues under the UNFCCC. And additionally, for those of us who are working on ocean observations, there's not just the COP process that we can think about, there's also SBSTA, so that's the subsidiary body for scientific and technological advice. And there's been a long-running work stream on research and systematic observations under that we can also engage in. Next slide, please. So that was a bit of the UNFCCC, right? The UNFCCC handles climate change policy, but as several speakers have alluded to, the ocean doesn't fit into one box, and it's important not to keep it siloed into one box. So it's not just the climate box, even though we are at COP28 right now, But the ocean connects us to this larger framework, international framework of policy and management. That includes the UN Convention on the Law of the Sea, of course, as well as the Convention on Biological Diversity, the Biodiversity Beyond National Jurisdiction Treaty, and of course, the 2030 Agenda, the Sustainable Development Goals. And so while we don't need to know kind of the interior workings of all of these, I think it is important as scientists to understand this landscape that our research fits into. Because when we do that, we can look at our research through these multi-solving glasses, right? So we can think about, given that there are limits to how much funding exists, for example, given there are limits to how much can be done, how can we think about how solving a problem we're working on can help somebody else solve the problem they're working on? I think it's also really important when we take this framework to think then about what trade-offs come with making decisions that maybe have one sort of positive outcome, but also have other types of negative outcomes, because being transparent about that is really important to making sure that our scientific recommendations actually get policy uptake and we can have good, meaningful conversations with decision makers around that. And then also it's important for us not to stay in the marine silo, right? We don't need to reinvent the wheel. There is a great reference also from terrestrial scientists who have been trying to look at these questions about spatial planning and how you balance different needs and environmental conservation. And so here, I just wanted to point to the UNESCO Man and Biosphere Program, because they have over 50 years of experience with over 700 biosphere reserves in over 100 countries. And I think that's a really great wealth of expertise for us to look towards. And some of those biosphere reserves also include marine systems in terms of how we can make sure that we are able to meet multiple priorities and how research can support those multiple priorities. Okay, next slide. And so just to finish this with a few practical tips, right? Because this is, we just took a look, kind of a very broad look at this large international policy framework. But really, I think the most important thing we can do as scientists is figure out what is the value chain for the knowledge that we're generating, identify the key stakeholders that are part of that value chain, and make sure that we are very, very clear that when we produce knowledge, we know exactly whose hands it goes into, because whether or not that knowledge will have any sort of a policy impact has everything to do with that next step, right? As scientists, there's only so much that we can do. And we need to make sure that that next partner is actually excited and interested and involved throughout this knowledge creation process, so we know that something happens with that knowledge. And so a key to this is engaging early and often in order to translate knowledge into societal value. And I think that it's very key for us to be able to talk about kind of different mechanisms and the value of different changes and what impact, relative impact different changes can make. And if we can kind of put our scientific outcomes in that type of a framework, and also be very clear about the uncertainties. And when we think about ocean carbon especially, I think kind of the uncertainties is a really important component of this, and something that Ocean ICU, I think, will be able to contribute tremendously to, because a lot of these processes are really important, but also in the deep ocean, they're very poorly understood. And so, yeah, thank you for your interest, and I look forward to the discussion.
Thank you very much, Natalia. That was fantastic. Now over to Dr. Pernille Schnoor for discussion on these last panels. Thank you.
Thank you so much for your presentations. I will start with you, Natalia, because for obvious reasons, as a former parliamentarian, I'm very keen on what you have just been presenting. And I think that your points about scientists that need an understanding of policy is very important. And I think I will, for the questions, we only have 10 minutes left, but for the questions for Fabio and Patrick as well, I will focus on this part. But I would like to ask you, Natalia, you're talking about the disconnect between science and policy as well. And communication is a critical part of a scientist, a researcher's job, to share information and findings beyond a firewall of scientific journals. and also beyond their own scientific community. Do you have any ideas on how we create this intensified dialogue between scientists, the public, and the policymakers?
Yeah, thank you for that question, Pernilla. I think that providing forums for scientists to engage in areas like, for example, COPs, in other political forums, like, for example, as a PhD student, as a postdoc, I also went and attended some kind of regional fisheries management organization negotiations. So I think whenever there is an opportunity for scientists to engage and get a better understanding for how policymakers and decision makers are considering the science that we're actively working on. Just creating kind of fertile ground to have these conversations. I think that's a really important part of it.
Okay, thank you. I would like to ask you, Patrick, you, in one of your slides, you said introducing spatial management measures is a challenge. I would like you to let us just pretend that I'm a politician, a non-scientist, and you were to explain to me what the challenges are. I would like you to do that to me, if you could, that please.
Yeah, well, it will be difficult in a few minutes, but
yeah, I know.
That's a very complex landscape because you have different interests and probably different objectives. So first, there is I would say, the institutional framework. We have different, at least in the Pacific. In the Pacific, we have already two tuna commission, international tuna commission, in charge of the management of these fisheries. So in the future, I guess they will have to they already work together for some questions, but we need to reinforce the collaboration between these international commissions, and there are also others in the other ocean. Then we have the issue of the sharing the resource between the ICs and the Pacific island countries, and the point that climate change may create some new situation where the biomass that was exploited in this EEZ of Pacific Islands is moving maybe more and more in the ICs. And so on one side, the international fishing fleets will move to the ICs, and on the other side, the Pacific Islands will lose part of their economical revenue. So it's a big issue here also. And plus, of course, all the challenge we have in the science to model, because we deal with migratory species, so we know that these tuna species have a very wide distribution. The example of the impact of El Nino event on the distribution of these species highlight clearly that everything can change in a few months. So climate change will add more uncertainty on that. So it's really a complex situation. Both in terms of science, but also, and maybe more, I would say, maybe more in terms of management and negotiation between the countries, the fishing fleets, and the Pacific Islands as well.
Thank you so much, Patrick. Fabio, I would like to ask you, according to the United Nations, avoiding the worst impacts of climate change would require 4.3 trillion a year by 2030. I know that numbers rarely speak for themselves, and as we have just heard from Natalia as well, without adequate interaction between science and policy, results will likely be ignored, or maybe even worse, be misunderstood. Do you have any ideas on how to enhance the practical usefulness and political relevance of the maps and theory that you have just presented today?
Thanks for the easy question. Uh,
Sorry about that.
well, no, it's okay. I mean, we need to get to the practical side of things. Yeah, I think, the tools me and other speakers have presented are first important step, quantify and know where things are and how valuable they are. Then the second step is to realize that we are getting these services for free, and if we don't pay to protect these services, then we will lose them or they will be degraded. So as Patrick mentioned, we need to we need to judge the trade-offs between the things we do. And so I think it's good to speak in different type of terms, not just the ecology or the oceanography, but also, the economy and the finance, because then we can play on the same field and try to understand that there's trade-offs if we fish too much or if we degrade certain parts of the ecosystems beyond a certain level, then we lose those services, and then we will have to pay to restore those services that we need later. So at least it starts the conversation it levels the playing field and allows to evaluate these trade-offs that we're making. And before, we didn't even know that we're making trade-offs. We were thinking fishing is free for all, let's just fish as much as we can. Now we understand that if we remove too many fish, we lose carbon services, but we lose also other ecological services. So you see now this, I think, increase the information that we have to make these decision and talk with on the same wavelength as outside of science.
Just to make sure I understand, I think it's very interesting with the maps you've been showing today, also with the small islands and their influence on this. When you say we have to pay, who are we in that context? Who do you mean by we?
We as humanity, because someone needs to, I mean, we are paying as humanity, but in the sense we need to reshuffle the economy. We need to reshuffle finance, global finance, so that those countries that need to make a decision whether they have a marine protected area or they have deep sea mining or they have like uncontrolled fishing, they can actually make a decision. They can be helped financially to decide towards a more sustainable pathway. But of course, we need to be realistic that making those decisions takes money. And so we need to, in these financial climate finance discussions, we need to factor this in. So that's what I meant. We as in the global climate finance and cooperation between nations.
Okay, thank you. I have a question that I would like to pose to the whole panel, and you can raise your hand if anyone wants to answer. I would like to ask you as scientists are also citizens. Do you think that as scientists you have a responsibility to advocate to the best of your abilities and to improve your advocacy and communication skills in order to do so? Will anyone try to answer that question? Mary? Yes?
Absolutely. I think that we all have a responsibility to do this, because in order for us to effectively communicate and also promote the use of credible information for decision-making, evidence-based evidence for the use of evidence in decision-making, then we need to be very, very clear, and we need to be able to take the message to the right places at the right time and know how to do that.
Thank you so much. Thank you. That was my last question. Thank you. think we only have 1 minute left, so.
With this, I'd like to thank everyone for the panelists for their fantastic contributions and for the audience for joining us. There will be recordings available at the registration website. And so you will be also contacted and the recordings will be shared with you in the future. So I thank you all very much. And I also look forward to the next presentations too on the Biodiversity Beyond National Jurisdiction Agreement. So thank you very much, everyone, and have a wonderful afternoon.
Thank you. Thank you. Bye-bye.
Right.
Thank you.